In January 2005, NASA launched a unique probe into space with a remarkable mission to discover the origin of water on Earth. This probe, called Deep Impact, traveled 270 million kilometers to reach a comet, an ancient celestial body believed to hold secrets humanity had sought for centuries. There is only one known place in the vast universe where human life can exist, our Earth. It feels as though Earth was designed for us, containing everything essential for life: water, food, and oxygen. Whether such a planet exists elsewhere remains uncertain. But for now, Earth is the only place where humans can live without assistance. 5 billion years ago, however, Earth did not even exist. At the edge of the Milky Way galaxy, where our solar system lies today, there was once a massive cloud made of dust and gases. Known as a molecular cloud, it contained dust particles rich in silicon, metals, and sand, formed from the ashes of dead stars that had exploded across the early universe. Unlike ordinary clouds in our sky, these cosmic clouds span up to 100 light-years. To put that into perspective, a beam of light would take an entire century to travel across one. Within these clouds, gravity plays a crucial role. Particles, pulled together by gravitational force, began colliding, releasing energy that heated the cloud's center. Over millions of years, the dense, spinning core grew hotter and eventually ignited into a massive fireball, the Sun. The leftover particles of the cloud continued to orbit the young Sun, giving rise to planets, moons, and ultimately, life. The concept of star and planet formation from molecular clouds was first proposed in the 1700s by Immanuel Kant and Pierre-Simon Laplace. Centuries later, with the advancement of telescopes, astronomers directly observed these dusty nurseries where new stars were born. Further breakthroughs came in the 1970s and 80s with radio and infrared telescopes, which allowed scientists to peer inside molecular clouds and witness stars forming. Yet one question remained: how did the process begin? In 2003, astronaut Don Pettit, aboard the International Space Station, performed a simple yet groundbreaking experiment. He observed how particles in microgravity naturally clumped together, similar to how salt grains stick in space. This experiment demonstrated how small cosmic particles could have combined inside molecular clouds to form clusters, eventually growing into planets. Around 4.5 billion years ago, such clusters formed in our own solar system. As they grew larger, some as big as mountains, their gravity pulled in more matter, much like a vacuum cleaner. Over hundreds of thousands of years, about 20 large protoplanets emerged. Through massive collisions, many of them merged, leaving behind only a few major planets: Mercury, Venus, Mars, and our Earth. In its infancy, Earth was no blue paradise. It was a fiery, molten ball, with surface temperatures exceeding 5,000 degrees C.